Any questions? They were easy. So many questions and they were easy. So why do you do such things, huh? 51. I forgot to go back and look at that pavilion rental. An apple farmer currently has 156 trees. Yielding an average of 12 bushels of apples per tree. Per tree. I lost my place. He is expanding his farm at a rate of, oh, there's that rate word. 13 trees per year. Expand. Right. That's what I would think. But let's finish reading. While improved husbandry? What is that? Oh. Y'all are so smart. While improved husbandry is boosting his average annual yield by 1.5 bushels per tree. What is the current instantaneous, I was waiting on someone to say it, rate of increase of his total annual production of apples? IROC annual production. Answer in appropriate units of measure. All right, so how do I find out how many he's producing per year, first of all? I need an equation. There's Dylan. Did y'all have trouble finding the multiple choice on the AP Classroom? Oh. There was an FRQ and a multiple choice part. Oh, okay, so it wasn't just you. Okay, I'll look and see. Okay. The packet? Oh, that one worksheet? Okay. All right, so let's come back to this problem. To find out your annual production, we're going to need the number of trees. It helps me sometimes to write what I need, and then how to find each one, times the number of bushels per tree, times the bushels each tree produces. Does that make sense? And that'll tell me how many apples I produce, right? So how many trees do I have? Plus 13 trees per year. I'm going to let my variable be the number of years, or T for time. So 156 plus, how many trees is it? 13 more every year. Does that make sense? That's a plus. So the number of trees I have is 156 to start with, and then 13 more trees every year. So depending on how many years it's been, I plug that in for X, and that'll tell me how many trees I've got. How about the number of bushels per tree? This is bushels per tree. 12. But every year, because I know how to do husbandry, whatever that is, then it increases 1.5 bushels per year. So it's 12 plus. You all okay there? Yes, everything in purple was given to me. Because I thought that in order to know how many apples I produce each year, I need to know how many trees and multiply that by how many bushels each tree produces. $8. Okay, so you could foil. I need to yo, I'm sorry, I have to leave this on today because Parker's homesick by himself today. That was Dylan. Remind me as soon as I finish this and I'll print it. Unless you need it right this second. Let me finish this problem and then I'll pause it and print it. Alright. So it asked me for the annual production, the instantaneous rate of change for the annual production. Currently, I guess we're gonna assume.
What would you plug
Okay.
in?
Well, we're not gonna use difference quotient. We're gonna use. What are we gonna use? The rules of derivatives. We're just gonna derive this bad boy. Yes, we can do that now. So I would probably use the product rule here instead of foiling it out. If you foiled it out, that's okay. Okay. I will. All right, so if I do IROC here, product rule says derivative of the first. What's the derivative of that first piece? 13 times the second plus the first one less u times derivative of the second. That is correct. You don't have to go over anything because it's not quotient. So now let's multiply it out. Yes. Well, constants become 0, and then anything x becomes just the number in front, the leading coefficient, the coefficient. Say again, no, I'm sorry. 156 plus, it's 19.5, but that was really close, plus 234. If I was filling it today, I'd have done that in my head, but I just wasn't. 1.5 times 13. We just did that. 19.5. So this is 156 and 234 is, what is it? 390. Waiting on all you mental math geniuses. 39. So that's, you were what? Foil it, you mean? All right, so there's my IROC. So it says, what is the current rate?
If you foiled it and then derived it.
You do that too. That's what Lizzie was saying she did. So yes, if you just foiled it here, and then you could find the derivative there. Yeah. Either way is fine. I want IROC when I called you what? Glizzy?
So then your answer is 390.
390. Now remember, units are very important. What is this? 390. Yeah. Here. This is all together. Remember, we did the total number of trees times the bushels per tree. So then we're looking at the total number of bushes each year.
So what is a bushel?
Like how much you get?
It's an amount. A bushel is an amount. So like a bushel is like a. Have you ever been to MacD and got peaches?
Yes.
The big basket, the big brown basket. That's a bushel.
It's like a cubic.
Yes or no? Maybe so. Could you set this up on your own and find the instantaneous rate of change? I feel like this one's a little bit easier than the whole Blue Boar Society one. What'd you say? I'm gonna be 100, probably not. It's when I have word problems, it's easier for me to set up. I always write down what I'm given, and then I always try to write down what it is I'm looking for and how to find things like that. It makes it easier for me.
On this quiz, what else did you do?
2-1 through 2-3.
Is it gonna be like majority quiz?
A lot of them.
Alright.
So the only like rules
Power rule.
Power, quotient, product.
That's it, right? One of those.
That's all we've learned.
We learned 4. What was the 4th one?
Okay, graphs. Yeah.
What was the 4th one? There was like, it's the top 4 on that sheet you got. But you took the sheet away from me.
Well, I gave you another one. You didn't get the other
Oh,
one.
what?
Some indifference, but that's
Oh, yeah, so.
yeah.
I mean, you know, like the constant. Goes to.
What else? What else? What else? What else?
Yeah, I need her to, I need my, I need her out. What thing?
Me neither.
Let me pause you two. 32. Did I not put the thing on there? I thought I did. Yeah. I haven't found the solutions online for this book yet, but I am looking. I'm looking. All right, 42. Find the tangent to the Witch of Agnesy.
Just the IROC skill.
Absolutely. It's all these different words that mean the exact same thing, but that's good that you're getting that now. And you're like, oh, that's stupid. It just means
Yeah, that is.
derivative.
What's this?
It says find the tangent to the Witch of Agnesy at the point 2, 1. I don't know what that is. I don't know. It's kind of like the Newton serpentine we did before. But the point that we're getting at is, again, it's the derivative, and then I'd have the slope and the point, and I'd write the equation of the tan line with the slope and the point. So let's do the derivative first. Derivative here is?
Okay, the derivative here would be 0 over
0 minus top.
Oh, it's the quotient rule, sorry.
Oh, I didn't realize that.
Quotient rule, because there's a quotient there.
8 times.
Right? All right, so this is really negative 16x over, and I'm going to leave this just like this. But, oops. Yes, that would be bad. Don't use the R word.
Because you would do, you would bring the exponent over.
That was 4x squared.
Minus 1.
So now I'm going to find the derivative at the point 2, 1, which is really y prime of 2, right? Look how different I write at different times. Somebody told me one time that they would never be able to use like a handwriting analysis on me because I don't write the same. Look at my y, my 2s.
I do that too.
Do you?
I do that too.
I think it's a sign of intelligence, actually. No, I'm just kidding.
I write my 2s and 4s different all the time. Local.
Negative 32 over 2 squared is 4, 4 plus 4 is 8, and 8 squared is 64. Looks like negative a half. Excuse me. So now I have a slope and a point. That's your slope, right? Because that's the derivative at the point. My point was 2, 1, so it's y minus 1 equals slope times x minus 2.
I'll get it.
Thank you, Van. Yeah, I would leave it like that unless it's specified to put it in a certain. Yeah.
I just wanted to know that.
Yeah.
Okay.
So,
I'm so happy for you and this stuff now.
can you plug into earlier? If you plug into to the
When
original,
do you plug it?
after you find the derivative.
So you don't have to like do the you don't have to do the bottom portion of this equation. Like you did,
You don't have to do what?
like when 4 plus x squared, you didn't actually square it.
I didn't. I plugged it in before squaring
You
it.
can do that.
You can. If you want to square it, you can. It just leaves more room for error. I try to do as little algebra as possible
Yeah.
before I get to plugging in because it leaves
So
more room
that's like
to mess up.
non-derivative either. That's not changing.
Yeah. All right, what else on your homework? 47.
Are we gonna get a little review thing done?
Are you what?
Gonna get like a little review thing?
Well, it's in the book, but yeah. When a rock falls from rest, because Wyatt stood on top for long enough and dropped his rock, and now he's giving it a break. So now a rock falls from rest near the surface of the earth. The distance it covers during the first few seconds is given by the equation S equals 4.9 t squared. In this equation, S is the distance in meters, and t is the elapsed time in seconds. Find ds dt and the second derivative also.
Oh, that's easy. Your first derivative.
My first derivative is just, what's 2 times 4.9?
Well, that'd be about 5. That's sorry, 9.8.
So ds dt is 9.8
And then
t.
your next one would be actually
It would just be 9.8. This would be the derivative. So whenever you take a second derivative, you look at the derivative prior to it. This is, yep.
I hate when it's
This is s prime. This is s double prime.
Is it at 1?
9.8.
and then after that it'd be 0 if they ask you.
Yes, if they ask for it again, it would be 0.
Okay, so you know whenever you know when they want that because they'll put an exponent like 2.
Say again?
Like you know they want the second derivative because they put the exponent over.
Yes, yes.
Like, I thought that, okay, so it was 9.8 squared, it was 9.8, 4.9 squared, and then 9.8 t, and then you move the 1 around, it's 9.8, then you have no.
1 minus 1 would be 0. T to the 0 would be 1.
So I thought it would be 1.
What? What?
Are you talking about
9.8 t, I thought it would be 1.
the derivative of 9.8t?
That would be
No, that's 9.8. It's always the derivative of the number in front. Okay, so let's think about the power rule a second. There's a 1 here, right? 1 times 9.8 is 9.8. And then if I subtract 1, I get t to the 0.
Oh, it becomes 1.
I
So
was
it's
doing 2 steps,
oh no, that's right. Okay.
and then whenever that happens, so that's like another step, a whole.
Yeah.
So when do you get 1 as your answer? Does it start with 1 as your 1? Like not on this specific problem. When do you get 1?
Yeah, if it's just x. Yes.
Negative.
So what does that mean, happen like with negative exponents?
Keep on going.
Oh yeah, there's like a different way to do negative exponents, aren't there?
Mm-hmm.
Wait, when there's a negative exponent.
There was something for
If I had,
like the derivative of or if it's not. What about that?
okay, I'll show you.
I was doing that on the homework. I just couldn't.
Okay, but the 2 would stay up top if you wrote it like that. But I would just keep it like this. I would multiply around negative 6x and subtract 1.
Where did you do that?
You go mango line.
Same rule. Multiply and subtract. So again, multiply and subtract. Well, if you've got a negative exponent, you can move that piece down to the bottom. I could keep going with this forever. Right. Yep.
Oh my
Um,
gosh, well, wait a minute.
Hold on.
You got you with a posture.
How about if Dylan said, what if it's something like this?
So you would do.
You just do it to the 1/3. And, whoop, my hand hit the. So the derivative is, so you multiply 2/3. I could do it again. Sure you could.
Please shut your mouth over there.
Oh, why did it go to 5? Why did it go to 5?
What's negative 2/3 minus 1?